Good afternoon. In this tutorial, we'll do the ASIC design of a design file named ALU, and the tool that we'll use is IC Compiler. So, similar to other tutorials where we have to take the license, go to labs, and here. For the IC Compiler, you have to go to this directory. In that, you have to go to this directory. In that, you have to go to this IC labs. Okay. Here, you have, here you have to create a directory of your own project. In this tutorial, it is test data. This contains the netlist of a RISC architecture based ALU. You will find it in the netlist directory. This is the, you can see it. This is the netlist of a RISC based ALU. This is a example design, and let's see its basic design using IC Compiler. Before starting, we have to edit a setup file similar to the prime time. You have to see where it is. It is here. Synopsys IC setup. Okay. Settings which we have to change are here. For this design, the settings has been done. This Milky Way library has been set up. You can check the path of Milky Way library. It is here. Let's get a Milky Way library. The technology file, the parasitic files. The changes which you have to make is the name of the top module for a design. In this case, it is desk_chip. You have to check the control file also. You have to provide the path to your netlist file. You can see, and the constraint file .spc, similar to what we have in the prime time. For that counter, we had constraint.spc. For similar to this design, we'll have recip.spc. We have to edit these things and then go back and then run the tool. Okay, the tool has been worked. The tool does have a GUI. Have to be very careful while doing this. So if you miss any step, then you have to again repeat. You have to go to File and create a library. Create library. You provide the path where the new library will be created. And here it is test data. Okay. And it give any name, let's say August 19, 2014. You have to provide references to technology file. It will be in this folder TF. Okay. You don't have to provide the path to this physical library file, but here you have to add the references to these files, and for that you have to go to Milky Way library, where it is here. Connect and one by one add all the references. I hope. Okay, then next this one. These are the macros for the design that can be utilized. You have to add all the files. Let's see. Okay. Then you have to check here, open library, and then okay. Has been created. That will come to know notice later if any problem persists. Then you have to set the parasitic files, set TLE plus maximum. You have to go back there. For maximum you have to add this. For minimum you have to add this, and for this you have to add this one, mapping one. Okay. So this has been done. Let's see, one indicates okay. Then you have to check the integrity of these files. Check TLE plus files. Okay, it passed all the three sanity checks. That's okay. Now you have to import the netlist file. File import read verilog. Okay, fine. If there be any error in reading the netlist file, it will show up here. If there is no error, it's good. A new window opens. It shows this rectangular area shows the die area, and these pink color cells show the standard cells. Slowly and constantly. So these pink color cells show the standard cells, and this uh, and you can see the RAM because this shows the macros using this design. Now let's proceed further, and then we will understand further. Here, here. Okay. Next is to apply the constraint. Go to file, import stc, and okay. Here, read stc. Then you provide the path to net constraint file. Here, here. If any constraints will not be applied, it will show error. Let's see. And this will make changes to design. just here, no changes. Proceed further. Now in that window, because we have applied a constraint, now we have to work in this window. Here you can interpret these colors with the help of this vertical hierarchy, what is here. So the first step towards backend design of your Verilog based project is floor planning. Go to floor plan, create floor plan. Here you can provide the co-utilization ratio 70% and aspect ratio. So here you have to check all these things and provide some values here, taking some random values. Okay, and see what happened. Got this in the picture. This is the core area, the rectangular area in the center, that is the core area, and on the periphery of it we can see the bonding pads with the port names attached, and these two rectangular boxes on the upper left corner represent the macros used in this design, and these pink color arrangement on the right side shows the standard cells of the design. Next is pre-route. Now that you have to go to derive PG connections. Go to manual, you have to enter these values GEDD, BSS, and you can understand yourself what is being entered. Okay, and applied. Let's see what happened. We missed something. Figure out what we missed. We did it. Okay, it is okay. Then again you have to go to pre-route. That we have only entered the values, and after we will create rings, those will be visible. Here you have to select this. Select 3D and select. Sorry, you have to go to the rectangular because you have to create rectangular rings. So select 3D, OK, and select BSS. And here you have to provide the values, offset, how much offset you want to keep. 1 here. We are taking random values. Okay, 1, 1, taking same for everything. And this you have to keep in mind, the same for everything. The left and right metal layers will be of metal 6 and the top and bottom will be of metal 5. I'll provide you a book of backend design where you can have understanding of these things. Okay, apply, and you can see here the result of creating rings. You see the rings have been created. Okay, let's proceed further. Again under pre-route, now you have to create, we have to pre-route instances. As name indicates, we are pre-routing the instances. Go to that pre-route. First you have to pre-route standard cells. Here, what you have to go to routing options. Fill empty rows, which you have to uncheck. This you have to check. Fill empty rows. Okay. Pre-route standard cells. Routing options. Then again under pre-route instances, apply. Cancel. Now you have to move to that other window, like create FP, get FP placement. See what happened. You can see what happened. All the standard cells got placed. They just got placed, and the macros got placed in the active area. Let's see, zooming in between the metal layers. Okay. Next to legalize FP placement. You should view the result of the command execution. Then only you will be able to understand what is going on. You will select a macro, then go to properties, and you have to fix it. You can see its fix is false, you have to make it true. Okay, apply. Okay, now this macro is fixed. It will not be moved during the process of optimization. Okay, fine. Now again going to that directory, place means to the optimal placement of the scanner cells. It will take time. And you should read all these things. And you can see the changes. Let's see what happens. Now we have to do the clock tree synthesis activity, and this can be done by this command. Remove clock underscore uncertainty all clocks. Okay, there is a record happened. Nothing interesting. That x forward optics rule all clocks, then 0 clock opt. It will have some interesting effect on the basic design. You will see it. And the result of this should be this flag, positive flag. Okay, here you have to see the results. We are getting positive flag or not. So this is a very comprehensive analysis. Here you can see the result of clock tree synthesis and optimization. This red and green color show the clock tree synthesis, and you can find in those log files which type of clock tree synthesis is this. Okay, now you have to finally route the design. That means make connections to standard cells. Up to this we have make the clock connections, synthesize the clock tree. Now it is to route the entire design. First we have optimized the design according to clock tree synthesis. Now after optimization we have to route the design. Route opt. This is the final command that will be for your design. Okay. So here you can see the results. Number of DRC violating path nets 0, route violation 0. You can see your design finally routed. This is a very interesting view which you can have for a design. A very nice view for design. Basic design is just like creating a colony similar to what we create. Okay, it's done with the basic design. Thank you to IC Compiler and thank you to all of you. Now after that you can write the GDS2 and all other things. From here export, write verilog, DTC, STF, TF, write stream. Write stream your options for GDS2 and OSS. Okay. Here you write the name and then OK. So the front end design flow of Synopsys is over. Hope you have learned a lot. Thank you.